Okay, we are going to continue. This is going to be test prep number 2 for the test coming up, the retake on Friday, mostly involving radicals. And so I just wanted to, in the previous one, on the test prep 1 that we did earlier today, I mentioned 2 problems I just want to show you really quickly. I think they were numbers 5 and 6. Pretty sure it was number 5. And it was something like the square root of 4x squared over 36x. And I asked myself, is 4 a perfect square? Yes. Is x squared a perfect square? Yes. Is 36 a perfect square? Yes. Is x? No. Alright, but since there's so many perfect squares, I'm going to go ahead and separate them, because that will simplify things immensely, right? Square root of 36 times the square root of x. So as I look at this, square root of 4 is 2, square root of x squared is x, square root of 36 is 6, and then the square root of x, right? And then I said, well, yeah, but I can't leave this in the denominator, so I multiplied both top and bottom by the square root of x, if you recall. This is called rationalizing the denominator, okay? And that's just going to give me 2x times the square root of x over, because see, I can't multiply those times whatever's inside, because you can't do that. You can only multiply what's inside times another thing that's inside a radical sign. So since these are not in radical signs, they have to just stay on the outside. And then here I have 6 times x, 6x. What I failed to notice, because I was focusing on the radical, is there are a few things I can do to simplify this. Look, x goes into x once, x goes into x once. Those x's cross out. 2 goes into 2 once, 2 goes into 6 3 times. So really, all I have left is 1 times that, or just that, the square root of x over 3. That looks much simpler, right? Much easier to comprehend. And then I believe number 6, we had the same problem. I didn't do something quite right. 7a to the 4th over 9a squared. Okay, and I noticed perfect square, perfect square, perfect square, and not a perfect square. But that's enough for me to just separate things out. A to the squared, a to the squared, because that's going to come out as a to the squared, right? That's equal to a to the 4th, all over square root of 9 times the square root of a squared. And so we got a squared times the square root of 7 over 3a. What I had not noticed is, well, a goes into a once, a goes into a squared a times. So my final answer is a square root of 7 over 3. A little simpler. Okay, so that's it. Now I wanted to go into, so that was just review of what we did prior. Now I want to get into adding. If you recall, adding radicals. Okay, so if we're going to add radicals, let's see, throw that one away. Okay, so let's say we have something like this. So we're going to call this, we're really, I guess I should put a little thing here. Adding, subtracting radicals. Just so you know what it's called. Okay, so let's say we do this. Let's say we have 5 square root of a minus 9 square root of a. Okay, with this, the first thing I look at is the square root sign and what's inside it. And I see that, look, they both have exactly the same thing inside it. Therefore, when they're exactly the same, these are considered like terms. So I can actually subtract the 9 coefficient. Remember, the coefficient is the number in front of the variable? Well, in this case, it's the number in front of the radical. That's the coefficient. I'm going to take 5 and subtract 9 from it, and then keep the square root of a after it. because that says I have 5 square root of a's. In other words, square root of a plus 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 square root of a. And I'm going to take 9 square root of a's away from it. So I'm going to take all those 5 away, and I'm going to take 4 more away, which means I'm going to have negative 4 square root of a's. That's my answer. Nothing else I can do. All right. Now we're going to go to, now we get a little more complicated. Square root of 32 minus the square root of 8. Now I really recommend you do not do anything in your head when you're doing radicals. That has only served to confuse more students than you can imagine. And I don't even do it. I mean, why, if I don't do it, why would you do it? So I think, okay, what is my largest perfect square that goes into this? Well, 4 times 8 goes into 32, but then if I did that, 8 is 4 times 2, right? So I know there's 4 into this plus, times another 4, that means 16. 16 goes into 32. I want my largest perfect square. So I'm going to say the square root of 16. I'm not writing 16 and I'm not writing 4, I'm writing the square root of 16 times the square root of 2. That equals the square root of 32. That's correct. And I keep going. What's the largest perfect square that goes into that? It's got to be 4, 9, 16, 25, 36, 49, 4. So I'm going to write square root of 4 times the square root of 2. Now I'm going to simplify. Square root of 16 is 4. And then I can't do anything else there. Square root of just times the square root of 2 minus square root of 4 is 2 times the square root of 2. Look! And now I'm looking at the radicals themselves. The numbers underneath the radical sign, they're the same. Therefore, these are like terms, so I can subtract the coefficient of negative 2 from 4. So I'm going to go 4 minus 2. 4 square root of 2's minus 2 square root of 2's gives me 2 square root of 2's. Right? Okay, so let's try one more. Let's try this. This is the kind that people are starting to have trouble with, I've noticed. When there's a number in front of the square root sign. 4 square root of 2, here, I'm going to just write this a little lower. 4 square root of 2, where was I? No, 4 square root of 12, sorry. 4 square root of 12 plus the square root, I'll put a number in here, 2 the square root of 75. Okay? So that we can start to see what we do with these numbers. Okay, so the first thing I do, I don't deal with this, because look, those are not like terms. I can't add the 4 and the 2, because this says I have 4 square root of 12s. That says I have 2 square root of 75s. I can't add them. They're not like terms. So I can simplify. So I don't do anything in my head. 4 times the square root of 12 is the same as the square root of 4 times the square root of 3. And then I do plus 2 times square root of 75 is the same as the square root of 25. Again, I'm looking for perfect squares. There's a perfect square. Times the square root of 3, right? So now that I've written all that all out, it's really hard to make a mistake. But if I didn't write all that out and I just sort of simplified in my head, I probably would have made a mistake. So I have now 4 times, square root of 4 is 2. I'm going to put a 2 there. I'm not immediately putting it into 8. I'm just doing it one thing at a time. Times the square root of 3 plus 2 times square root of 25 is 5 times the square root of 3. Now I get to simplify. 4 times 2 is 8. 8 square root of 3 plus 2 times 5 is 10. 10 square root of 3's. Oh, look, I have 8 square root of 3's, and I'm going to add 10 more square root of 3's to those 8. So I have 18 square root of 3's. So that's 18 square root of 3's, and that's my answer. Okay? It's just a matter of making sure you write everything out. You really would have to try really hard to make a mistake if you write this all out. But if you don't write it out, you don't have to try very hard at all. It's really easy to make a mistake. write everything out. It will make a huge, huge difference in your success on the test. Guaranteed. I think we're almost done with the adding. Let me just think if there's a couple more just to practice. Sometimes people get sort of freaked out by something like this. Let me think, we did 3, right? So here's number 4. When we have something like this, the square root of 50x minus 2 square root of 12x plus 3 square root of 2x. Oh, well, that looks kind of scary, doesn't it? And they're not like terms. They're all different. So I'm going to say I've got to simplify. This one, because I see this one is already as simple as it gets, I have a pretty good idea that since a math teacher gave me this problem, I'm probably going to be able to, on at least one of these, I'm going to probably be able to, 2 will go into at least one of these. And I'll be able to have something left over. Maybe not both of them, but we'll see. So, sure enough, look. 2 times 25. 25 is my perfect square that goes into 50. So I'm going to just write everything. I'm not going to do anything in my head. That is the same as the square root of 25 times the square root of. I could say 2 and then times the square root of x, but I'm realizing I'm not going to be able to go any smaller from the 2 or the x, so I'm going to just keep them together. Alright? And then I have minus 2 times the square root of 4 times 3, right? The square root of 4 is that's a perfect square, right? Square root of 4 times the square root of 3. Now I know square root of 3 is as low as I can get. I'm not going to get any lower or simpler than that. So I think I'm going to just include my x right with that 3. I could have written square root of 3 times the square root of x, but then I'd have to combine it later. So to me that's kind of a useful thing there. And then plus 3 times, I can't really do anything there, 2 square root of x. 3 times the square root of 2x. Now I simplify. I've got 20 square root of 25 is 5. Square root of 2x. So I have 5 square root of 2x's. That's good. I have 2 times square root of 4 is 2. Square root of 3x. Plus 3 square root of 2x. Oh, that's interesting. There's my square root of 3x. There's the square root of 2x and square root of 2x. I'm going to put these next to each other for now. I can do that because of the commutative property. I don't have to do it this way, but I don't have to move them over before I do it, but I'm going to just so you can see. So I'm moving this one next because those are both like terms, aren't they? And then this last one here, 2 times 2 is 4, times the square root of 3x. That's not a like term, so I'm going to have to leave that there as is. But this says I have 5 square root of 2x's, and I've got then somebody added to that 3 more square root of 2x's, so I have 8 square root of 2x's. So, there we go, 8 square root of 2x minus 4 square root of 3x. And that's as far as I can go. There's nothing else I can do. Absolutely nothing else. I think that's probably enough on adding and subtracting radicals. But I am going to add one more thing. I'm going to actually do a couple things on multiply too. I'm just trying to get a few. This is all review now, so it shouldn't be too bad. Now we're going to do multiply radicals. Okay, so now we're going to go multiplying. We've already done dividing, right? So all we have to do now is multiplying radicals. Multiplying radicals comes in a few different forms. Oftentimes you'll see something like this that was on the test. Well, something like this was on the test. 5 times the square root of 5 squared. Well, that's the same thing as saying 5 square root of 5 times 5 square root of 5. Now, some people started doing weird things. They thought this was a FOIL problem. They started, well, 5 times 5, 5 times the square root of 5, square root of 5 times 5, square root of 5 times the square root of 5. But that's not, there's no plus sign. This is not a binomial, and then this a binomial. That's what FOIL is all about. Where you have, FOIL is something like this. You have the square root of 2 plus x times the square root of 5 plus the square root of 3. There's a plus sign there. These are both binomials. Binomials. This is a monomial. This is 5 times this. There's no plus or minus. It's just 5 times the square root of 5 times 5 times the square root of 5. So it's not going to be like this. That's not binomials multiplied times each other. That's what FOIL is. It's if you have two binomials multiplied. So all I'm going to do here is say 5 times 5. I can only multiply this 5 times something that's outside of the radical sign. Right? So the only thing I can multiply it is this. 5 times 5 is 25. And then the radical 5, the square root of 5, and the square root of 5, I can multiply those 5's together. The square root of 5 times the square root of 5 is square root of 25, which is 5. Alright, and that 25 times 5 is 125. And that's my answer. So, I think you get the idea on those. I'll do one more. For square root of 2 squared, well, it's just going to be 4 square root of 2. Whoops. What did I just do? 4 square root of 2 times 4 square root of 2. 4 times 4 is 16. Square root of 2 times square root of 2 is 2. So my answer is 32. So it's pretty straightforward, I think, those. Now we're going to do those, the ones that require the distributive property. Square root of 8 times 2 plus the square root of 7. Alright, so I'm going to do my distributive property. This times this, and then this times this. Alright, so 2 times the square root of 8. I can't make that the square root of 16 because this is not inside a radical sign. So I can never touch that 8 with this 2 because this is outside of a radical sign. This is inside a radical sign. They're completely untouchable, right? So the only thing I can do is put the 2 on the outside next to it. So I have 2 square root of 8 plus square root of 8 times square root of 7. Now I have these numbers are both underneath the square root sign, therefore I can multiply them. 8 times 7 is 56, so I've got the square root of 56. Now, I happen to know that 4 goes into 8, right? So I actually could have simplified this. So let's go further. Let's see what we can do here. We've got equals 2 square root of 8. Oh, we've got, oh wait, we got a square root of 8 there too. Plus, oh, that's interesting. Okay, well, let's see. 4, what does 4 go into? 4 goes into 5. 4 goes into 5 once. 4, 1, 16, 4, right? Okay, so 4 times 16, oh my gosh, you're kidding. That's a perfect square, and that's, oh wait a minute. 4 times 14, sorry. 4 times 14 is, yeah, 4 times 14. Okay, so now, okay, so we're going to redo this. We're going to say square root of 2 times the square root of 8 is the same as 2 times the square root of 4 times the square root of 2 plus, this is the square root of 4 times the square root of 14. So now let's see what we've got. 2 times the square root of 4 is 2 times the square root of 2 plus the square root of 4 is 2 times the square root of 14. Right? And then that's 4 square root of 2's plus 2 square root of 14's. Now I no longer have any like terms. I'm done. That's it. That's my answer. So that one was a little trickier. Alright, so let's erase all this. We're just going to do a few more of these multiplies so you get good at them, and then we're done. Let's see, how about, I forgot what number I was on. 1, 2, 3, 4, I have not a clue. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 maybe? I don't know. I'll just say 7 just in case. I could be way off. I don't know. So anyways, how about the square root of 3 times 5 minus, I'm going to say 2 times the square root of 3. Alright, so I've got a, again, this is a distributive property, right? So it's going to be this times this, and this times this. I'm going to do it vertically here. 5 times the square root of 3, again, not under a radical sign, yes under a radical sign. They're untouchable. I cannot multiply them. I can just put the 5 on the outside. So that's what I'm going to do. 5 square root of 3 minus 2 is on the outside, but this is on the inside. So I'm going to have to just leave my 2 there. Square root of 3 times the square root of 3 is 3. So I say times 3. Look at that. 5 square root of 3 minus, so my final answer is this. 5 square root of 3 minus 6. That's my answer. Okay, 8. I guess that gives you an idea. Let's do one more, just to really get really good at them. Okay, square root of 10 plus 8 square root of 2. Okay, parentheses, binomial, monomial. It's a distributive property, right? Square root of 2 times the square root of 10 is the square root of 20. Oh, I know how to do that one. Plus square root of 2 times 8 times the square root of 2. Well, first of all, the 8 is on the outside. I'm just going to put the 8 there. Can't really multiply the 8 times the square root of 2. But, look, square root of 2 times the square root of 2 is 2. Look at that, times 2. So really, what I have is, I notice I can simplify this, because 4 goes into this. So I could write it as the square root of 4 times the square root of 5 plus 16. So 2 square root of 5 plus 16, and that is my answer. Looks like 66. That's supposed to be a 16. Alright, so that's as far as I can go. Alright, so the last thing I want to do with multiplying is foiling, so that you can see the foiling. A lot of people messed up on the foiling. We'll just do 2 of those. 8 maybe? 9. I'll just assume I'm at 9. Okay, a FOIL. Okay, let's try 4 plus the square root of 6. 4 plus the square root of 6 times 3 minus the square root of 6. Okay, so this is a binomial. Remember, binomials are 2 terms that are separated by a plus or a minus sign. That's a binomial. That's a binomial. So I'm going to FOIL. This is what I'm using. FOIL. First, outside, inside, last. Which is the same as doing this. It's the same as saying, okay, well, it's this times this, and this times this, and this times this, and this times this. Right? This times these two, and then this times these two. That's all FOIL is. First, this and this. Outside, this and this. Inside, this and this. Last, this and this. That's FOIL. So I don't even think FOIL, really. I just think of this times this times this, and then I go this times this times this. Distributive property twice. That's all I think of. 4 times 3 is 12. Okay? 4 times negative square root of 6 is negative 4 times the square root of 6. Okay? I'm done with my 4 now. Now I go to my 6, square root of 6, and multiply that times this and that times that. So square root of 6 times 3 is, and it's positive, so positive 3 square root of 6. Square root of 6 times negative square root of 6 is definitely going to be negative, because positive times negative is negative. Square root of 6 times square root of 6 is 6. Alright, so now it looks like we're done, but we're not. Because look, we have like terms here, and we have like terms here. So 12 minus 6 is 6. Negative 4 square root of 6s plus 3 square root of 6s is only negative 1 square root of 6s, right? Negative 1 square root of 6s. And that is as far as I can go. That's my answer. Okay? So that is FOIL. One last one. Maybe I can just leave that up. Last one, and then we are done. Hope this hasn't been too long. I forgot to time it, so I don't know. But let's say we do this one, because this is a FOIL problem. 6 plus 3 square root of 2 squared. That's FOIL, because that's a binomial times itself, times another binomial, right? So I'm going to write it 6 plus 3 square root of 2. I always write out the whole problem like this. I never try to FOIL it from this with this there. Never, never, never. I would get so many of them wrong if I did that. I know my limits, and that's beyond my limits. Okay. Okay. So again, it's going to be this times the first, this times the last. The inside times the inside times the last. Okay? So 6 times 6 is 36. 6 times 3, not square root of 2. 6 times 3, because that's on the outside. That doesn't have a radical. So 6 times 3 is 18 square root of 2. And it's positive. Now, 3 times 6 is 18 square root of 2's. Okay? Right, you saw that? 3 times 6 is 18 square root of 2. And then finally, the last and the last, right? 3 times 3 is 9. Square root of 2 times square root of 2 is 2. That's 9 times 2, which is going to be 18. So that is 18. 18 plus 36 is 54, I believe. So we've got 54, because that was a like term, and this, which is now 9 times 2 is 18, that's a like term, right? I added those together, I got 54, and then I'm going to add these together, plus 36 square root of 2's, and I am done. And that's my answer. Pretty straightforward. So tomorrow we're going to deal with equations, solving equations, which I actually think are the easiest of the bunch. We have now covered all of the, what I consider the more challenging radicals. So I hope this is useful. I think sometimes just to see a lot of problems done sort of helps your brain start to understand how it works. Anyways, that's it.